Okay, let's go. We're going to talk about two rules today, product rule and the quotient rule. And the product rule is for when we have the product of two functions. Now, if you remember, Tuesday in class I said, don't do this. Don't say that the derivative of the product is the same as the product of the derivatives. Don't do that, because that's not true. The sum of the derivatives is the same as derivative sums. The difference, etc., is the same, but this is not the product rule. The product rule is a little more in depth, and we'll go through it here. Basically, this is what the product rule says. That if you have the derivative of the product of two functions, and let's call them f and g. Sometimes you'll see them as the product of u and v. Sometimes you'll see it written that way, u times v. Well, the derivative of this product, as noted by this prime, will that be the derivative of f times g, just normal g, plus normal f times the derivative of g. The way I like to think about this, if you think of two functions, here's the first, here's the second. We got to take the derivative of first times second plus first times derivative of second. Or the way I learned it, the order doesn't matter, but I always remember it as first times derivative of second plus second times derivative of first. You might see some u and v notation, and so if u is the same as f, well, f prime, that'd be du, its derivative, and this is v, plus, well, this is u, and this is dv. You might see this notation somewhere. Okay, but the thing is, when you have a product of two functions, you notice here that it is not f prime times g prime. Don't do that. That is wrong. In fact, let's really cross it out. The derivative of the product of two functions is f prime times g plus f times g prime. You also might see it noted like this. You could see the derivative of f times g is f g prime plus f prime g. Now the order here doesn't matter. You can have this one first and that one second because it's addition. But just when you have two things, you need to have one alone times the derivative of the other, and the derivative of the other times the one alone. So let's look at some examples. Alright, so let's say we have this example here. Let's say we have this function h, and let's say h is defined as x squared plus 1 times the quantity 3x cubed minus 4x. And it says find h prime and write the equation of the line tangent to h at 1. Okay, so we'll do this h prime first. Find the derivative. Now, we wouldn't have to use the product rule here. We could actually just FOIL this out. We could get rid of these parentheses, take this times this, but that won't always be the case. We won't always be able to do that. So it's good to start using the rules that will apply to these functions. So here we have the product of two functions. So I'm going to call this one f, and I'm going to call this one g. So there's my first and second. So h prime is going to be, so I'm going to take first times, now I'm going to write it out as the derivative of the second. So there's f times g prime plus second times derivative of first. So there's first times derivative of second plus second derivative first. Well, now I just need to clean this up and do my work. Now I'm going to use the power rule to help me. We remember that the derivative of x to the n is n times x to the n minus 1. Okay, so here we have, let's just simplify this now. We need to find these derivatives. So here's x squared plus 1 times, okay, what's the derivative of 3x cubed minus 4x? Well, that'd be 9x squared minus 4 plus 3x cubed minus 4x times the derivative of x squared plus 1, which is just 2x. The derivative of 1 is 0. And now we got it. Now, I could clean this up a little more, I guess. But I'm just going to leave it like this for now. Now let's go to the second part. It says, and write the equation of the line tangent to this function at 1. Okay, so now it's kind of an extension more of the problem. We know we need two things to write the equation of a line. We need a point, and we need a slope. Well, the point, it's 1 comma something. So let's plug 1 into the function. We need h of 1. Well, that'd be 1 squared plus 1 times 3 times 1 cubed minus 4 times 1. Just plug in 1. 1 squared plus 1 times 3 times 1 cubed minus 4 times 1. Well, that's 2 times 3 minus 4. So if h of 1 is negative 2. So that's our point. Now we need the slope, and the slope is h prime. So we need to find h prime at x equals 1. Well, here is h prime. I just need to plug in 1. Well, that'd be 1 cubed plus 1 times 9, 1 squares minus 4, plus 3, 1 cubes minus 4 ones, times 2. And now let's clean that up. So, because this will be the slope of my tangent line. So that's 2 times 5 plus negative 1 times 2. So that's 10 minus 2, which is 8. And so now I have the point, and I have the slope. Yay, colors! And so now let's just use the point slope formula. Y minus y1 equals mx minus x1. So that'd be y minus 2 equals m, the slope of the tangent line is 8, times x minus 1. Now let's go ahead and practice cleaning this up. So this is y plus 2 equals 8x minus 8. So y equals 8x minus 10. So that would be the equation of the line tangent to this function at x equals 1. Alright, let's look at another example. Let's say this is our function. Let's say we want to find the derivative of this product of two functions. Okay, so I'm going to say that this is my f. Sorry about that, my phone rang. And this is my g. And I don't know how to pause the video. I'm just doing this in one take. Sorry about that. Alright, so I know I need to take the derivative will be first times derivative second plus second times derivative first. Okay, so I'm going to take first times, I'm going to go ahead and just write out derivative of second. Now eventually you don't have to write this out, eventually you'll just do this derivative as you're doing it, but I'm going to write it for now. Plus second times derivative of first. Now, we talked about this, and there's a good chance, let's start doing it right now. The square root of x plus the cube root of x to the fourth, we need to think about that as a power. Well, this is x to the 1/2 power, and this is x to the 4/3 power, because then we'll use the power rule. Okay? One way to remember these fractions, x to the m over n, the n becomes, there's an announcement. Oh my goodness gracious.
If you're in the building, please come to the office. Thank you.
That's funny. Yep, I'm at school. Ha, that's funny. Okay, sorry, where was I? This number comes here into the index, x, and the m is here. Now you can also write it as the nth root of x to the m. The order you do that doesn't matter, but you do need to know how to make these radicals into powers. Okay, so let's keep going. So here's first times derivative of second plus second times, okay, this derivative just use the power rule. 1/2 x to the 1/2 minus 1 plus 4/3 x to the 4/3 minus 1. But we should clean that up. This would be 4x minus 3 times, that's 1/2 square roots of x plus, okay, 4/3 minus 1 is 1/3, so that's 4/3 the cube root of x, x to the 1/3. So this would be the derivative of this function. So that's the idea of the product rule. First times derivative second plus second derivative first. There's two things. Make sure you have one left alone times the other derivative, and the other left alone times the other derivative. Okay.